Hello everyone, I'm going to go ahead and review with you guys finding limits using a graph. So this is a part 2 of what we learned yesterday. So let's go ahead and begin. I'm going to go ahead and use PearDeck just to see, first of all, like how it is. It's been a while since I used PearDeck personally, even though we use it every day. So let me see if I can get this experience. Ooh, all these pretty colors, right? So for what we're going to go ahead and do, sorry, I'm on a different device today, is I went ahead and gave you guys this answer key from the do now from yesterday, the exit ticket, sorry. And I gave some answers because I saw a lot of us were a bit confused on what the function means. So let me go ahead and say that. And what the limit means. So remember, a function, that's pretty much what we learned in our Algebra 1 classes. We're asking for the y value when the x is 0. So at x is 0, we have this y-axis right here, and we're looking where the solid dot is. So when our x equals 0, and we have the point -4, 0, -4. And as you can tell, my handwriting is not better on a different device. That's awesome. So that's why the y value is 4. For when the limit approaches 0, the reason I said that is because if I approach from the left side, right, my y value, my limit from the left, right, as x approaches our 0 from the left, the little minus sign on the exponent, we have this about what I would say a little bit less than 1, so 3/4, something like that. And when we approach from the right, we get to see the limit as x approaches to the right, the little plus sign exponent, we get to see that it's a -4. So we have this, what, I don't know, 3/4. Whoops. Well, it's really bad for me. It's not equal to this -4. Well, the struggle is real. Alrighty, let's go ahead and, ooh, brown. Let's go ahead and see this one. -1. -1 right here. As the limit approaches -1. I'm sorry, as the limit approaches 1 from both sides. So here's 1, right? And the graph from the right-hand side, you can see that it's going to go ahead and go to this y value of -1. So we can see that on this side, it goes to this -1, this point right here. And as I'm coming from the right, it's going to go ahead and go to this, oh sorry, from the left, it's going to go ahead and go to this, also this -1. So we get to see that the limit is this -1 right here. Super cool. Okay, so that is how we came about those answers. Okay, so today we're going to go ahead and continue on that because I felt like we didn't get the concept as much as we wanted to, as much as I wanted to. And since it's just the intro, I don't mind if we get take a little bit longer to get the nice foundation here. Okay, so these are your notes, so go ahead and write these down. So you can pause the video, write these notes down, and we can see that I'm gonna go ahead and notice these little points right here. So you see this -1 right here on this this C. I forgot to edit on this one, but this little minus says that you're approaching C from the left, and you're approaching C from the right if it has that little plus sign. Okay, and I forgot to label it right here, but right here in this jump is where I wanted to put C. I accidentally forgot to type it right there. And if it does not have an exponent under the limit as x approaches C, that means you're approaching from both sides. So here we can see that if we approach the left, from the left, and if we approach from the right, since we have a jump, in this case the limit would not exist. However, the limit from one side would exist, right, if we approach from the left and if we approach from the right. Okay, hopefully that makes sense. Go ahead and write down. Okay, let's go ahead and try the next one. Alright, so let's go ahead and do some practice problems. So let's do red. So on the first one, I'm asking, what is the limit as x approaches 1. I'm sorry, as x approaches 2. Notice it does not have a little plus sign or a minus sign, so that means what's happening for the graph as it comes from the left and what's happening as I come from the right. So we're thinking about like our y's, right? Our y values. So in this case, we see that this point, that means as I come from the left, as I get really, really close from the left and really, really close from the right, my y values for both of them is going to be 3. So my limit is 3. Okay, let me go ahead and try the next one. What happens as I approach x equals 4, right? This 4 right here. So on the left-hand side, I'm going down, 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 down to this y value of -3. And from the right, let me do a different color. I'm going this way, right? And the same y value. So in this case, my limit is going to be a -3. Oops, -3. Okay, awesome. Let me go ahead and bump up the rigor a little bit. And I'm going to go ahead and give you a graph with a hole. So I want you to try this one. So hopefully you were able to see that as a limit as x approaches 2, right? This is my x equals 2. What is my y value? Well, my value gets really, really, really close to this hole. And remember, the limit is approximation to this, so my limit is 4. Now, some of you guys might have said that the limit was 2 because there's a solid point at x equals 2. Now, that, however, is actual location of what x equals to. So in this case, when x equals 2, my y value equals 2, because the other one is a hole, a removable discontinuity. Okay. Alrighty, let's go ahead and try some more. So we have these ones right here, so I want you to pause the video and give these a try. So we have as the limit as x approaches 2. Hopefully you guys were able to see that it's going to be from the left, it approached a y value of 2. And from the right, it approached a y value of 2 as well. So my limit is 2. That is very different from my actual location. My location of this right here is the height of 1. So when x equals 2, my y is 1. Okay, let's go ahead and try the next ones. So go ahead and pause the video and give this one a try. Okay. So on this one right here, we have the limit as x approaches 3. Now, I want to put this one first, but you can go ahead and analyze by parts. So I'm going to go ahead and try with the left right here. So remember, when the limit, I'm going to go ahead and write that right here. The limit as x approaches, a value c, and it has a little minus sign, that means the left. Oh, I can't. Right. And if it was a little plus sign like this one, this means it's coming from the right. I don't know if it's Peardeck or me, but I'm struggling. Alrighty, so let's go ahead and try it. So I'm going to go ahead and do if I come from the left, right, the little exponent on the number is a minus sign. So you can see that this right here, because this is clicked, I don't know. Okay, someone's going to have to teach me. So this right here, we can see that my y value, right, my y value, the highest I got, the closest I got was a 3. Okay, from the right hand side, let me do that one in pink. Ooh, pink. So we get to see that this one right here, the y value, as I got close from the right, the y value approximately is 6. Whoops. There you go. Now, what we get to see here is that my left does not meet my right. So therefore, the limit does not exist. I don't know. So maybe I should be using some sort of app or something. Okay. Oops. I did not do that really good. Did it restart? Oh no. Oh, just kidding. All right. Is that better? RIP. All right. So we get to see that the limit from the left, the limit from the right is not the same. So therefore, it does not exist. Of course. All right, someone's going to have to teach me how not to get all these technical difficulties. since you guys use it more than me. Okay, and the actual location, right? The actual location. Sorry, I'm struggling to pick what colors to use. Of 3 is this solid dot right here. Okay, which is 6. Okay. All right, let's go ahead and try the next one. We have this limit's right here, so I'm gonna do the left one more time. So the limit as I approach 4, right? The x value 4 from the left is this height of 4. Oops. 4. And as I approach to from the right, right? As I approach from the right, I get this y value, this height of 2. So once again, my x and my y, my left and my right are not the same. 4 is not the same as 2. So there is no limit. It does not exist. Okay? So keep that in mind. The limits are different. This does not exist. And, sure, red. What is the actual value of 4? So at x equals 4 right here, what is my y value? Well, you can notice that there is no solid dot anywhere there. So this does not exist. There you go. I'm getting the hang of it. Maybe I was on a different thing. Okay. So this is the meme I have for you guys today. So the y value, keep in mind, it's a function with respect to x. So if you see these right here, that is what I mean. Okay. All right. One last one, and I think I'm gonna struggle a little bit. But what I also want to go ahead and give you guys a little feel for is the piecewise functions. Okay, so piecewise functions, they look a little intimidating, but they're actually not that bad. You're pretty much graphing multiple functions with given restrictions. These ones right here. And plus, this is good review from our unit too. Okay, so let me go ahead and check this out. So I'm going to look at these little lines here, these little restrictions first, and I'm going to see, okay, are they from least to greatest? If so, I can start graphing that. So the first one says it's going to behave like an x squared everywhere it is less than -1, right? And we know a little x squared is a little happy face parabola. X plus 2 whenever it is from -1 to 1. So a little linear that's been shifted 2 units up, something like that. Whenever x is 1, it's 2. So this is going to be a point, right? A point at 1, 2. Okay? And last but not least, we have a linear with a negative. So it's going to be a line downwards. That was shifted 3 units up. Okay, so let's go ahead and graph it. I like to go ahead and divide all of my little sections. So keep in mind, I'm gonna draw vertical dotted lines. Those are not vertical asymptotes. So at -1, which is right here, I'm gonna go ahead and make these little lines for my reference only, not for vertical asymptotes. There's no vertical asymptotes anywhere. And then at 1, so something like that. Ooh, it's a tiny one. Okay, all right. So I have something like that. Now I get to decide. So I'm going to draw the first one, the x squared. Okay, so we know ideally our x squared is a parent function, right, that goes like this. So 1, 1, 2, and 4, something like that. And it keeps doing that. And on the other side, it does it the same. I'm not going to draw it because I only want the part that is less than -1. Keep in mind, the inequality is open, so I'm going to make sure this is an open dot, and this is right here. Now, I'm going to go ahead and erase the blue because I do not need that. There you go. Ooh, that's nice. That was going to delete the whole thing. Cool. Alrighty, so I have something like that. The next one is my line x plus 2. Notice that this one does have a little less than or equal to sign. So I'm going to go ahead and evaluate this right here. So when it is -1, I'm going to say -1 plus 2. That's a positive 1. So at -1 is a positive 1. So I have the actual point right here. And then it's going to continue doing that. So when x is 0, if I put a 0 right here for my x, plus 2 is 2. And you can see it's a linear, so the slope will be the same. But keep in mind, this inequality is open, so I'm going to leave that open like that. I'm going to use my handy-dandy eraser to make sure it has a nice little circle. Awesome possum. Okay, and I can connect those lines just like that. Okay, all right, the next one is just the dot we agreed on, and this is a point 1, 2. So let me go ahead and use a different color. Have I use orange? No, I have not. So 1, 2. So 1 to the right, 2 in height. 1, 2 is right over here. Okay, and last but not least, we have pink. Let's use pink or brown. 3 minus 1. So we can see that whenever my x is greater than 1, we will have the line 3 minus x. So we can just substitute values. In this case, if we have a 1 here, that's 3 minus 1, that's a 2. And we already knew it was going to pass through this line right here from our previous point. Okay, and then we can see the slope is negative 1. Whoa. So it should continue doing this like so. Something like that. And since it is all the numbers greater than 1, we need to make sure it has this little arrow, like so. Awesome possum. So I know it took me a long time because I'm using PearDeck, but you guys can also do it on paper if this is easier for you guys. Okay. So let me put that arrow so it don't make sense. Okay, cool. Awesome possum. Now we can find these limits. Okay. So the limit as the function g, right? The composite function g approaches negative 1. So we know our negative 1 is these, and I could erase these now since these were just my restrictions and not vertical asymptotes. So I get to see at negative 1 right here, the graph is approaching this y value, right, which is also 1. So from the left, it's going to this y value, and from the right, it's also going for this y value, which we know is a height of 1. For my 0, we get to see that the 0, right, we're approaching this value right here, the y value of 1, 2, from both sides. I'm going this way, and I'm going this way. And last but not least, let's use brown. How about my, as I'm approaching 1 from both sides. Ooh, this one's right here, about 1. So I'm approaching this value. You get to see from my left, it has a height of 1, 2, 3. From my left, I have a 3, and that is not the same as from my right when I'm approaching a height of 2. So this one does not exist. Okay, awesome. So hopefully this helps, guys. The next 4 questions will be on your own, but feel free to ask me questions if you do need that support. Okay, and I will be continuing my regular lessons on Monday, and I do hope to see you guys back. Okay, so reach out to me. I'll quickly show them in case you want to do them here. Okay, you guys can do them on your paper, or you could do them on PearDeck. If you do have tips about how to not to struggle as much on PearDeck, please let me know. I also attached some really good YouTube videos. You can click on these links and they will take you to these YouTube videos that are also very helpful. Okay, alrighty, thank you for watching, and I'll see you guys on Monday.